So hello everyone, this is a 240 volt DC battery installation done in a power plant. The DC battery acts as an emergency backup for both for control instruments, for the turbine control and the boiler management system. It gives it acts as a source of voltage, electricity supply in case when there's an emergency, when there's a shutdown or grid collapse. So the batteries come up for control. So it's also for control for the DC breakers, the protection system for the electrical transmission system. And finally, it also acts as a supply for the lubrication system for the turbine, for the seal oil pump and the flushing oil pump, emergency flushing oil pump. So you need to have DC voltage, both 240 volt DC and 110 DC. 110 is for the control and the 240 DC is for the pumps. So we are seeing the connection of the batteries in series. As you can see, they were removed from the racks, were put into the racks and connected in series. That's positive to negative until we achieve the 240 DC. So since each battery volt is 2.2 volt actually, but the rating is 2.2, so you connect each of them in series, positive to negative, all of them until you get 110 for the control part and 240 for the other part, for the lubrication oil system part. So we can see now this is the voltage for each cell, which is 2.2 as I just said. When you connect all of them in series, it will combine to give you either 110 or 240. So this is very crucial. Without this, starting a power plant is extremely risky because there could be emergency shutdown, there could be problems and all those things. This is a picture of the connection. I was involved in connection. As you can see, my colleagues, people in my department were there connecting all day, all night, from November to December 2023/2024, thereabout. So we're all connecting, removing the old batteries. The old batteries had been spent out, and we're connecting the new ones. We had to wear our PPE so that in case there's a short circuit, it won't injure us or hurt us, or there's a spark or fire or something. So it was a tough process. We had to work with external laborers, we had to make sure that we are careful not to breach the battery terminals, do not cause a short circuit in any of them, do not overload the batteries, make sure they are neat, make sure they are strong, and we have to be careful because these batteries are over 100 kg for one battery. They are big and they're heavy duty. The capacity of the battery is 1500 Ah, 2.2 volts, about 100 kg per cell. So you're getting over 112 cells in series for the 2.2 to achieve 240 DC. You actually achieve more. You achieve 253 thereabouts. You connect them in series. So you need lots of support, lots of care, lots of electrical knowledge, lots of stamina, and all those things. So moving on, just pictures around, and just chilling and just having a good time thereabout. So after the connection was done, we are all happy as a team. We achieved it. We checked the terminal voltage, that is the total end voltage. We got about 253, which therefore shows that each connection is good. You make sure that the terminals are tight, they are firm, and they are covered so that even if there's leakages from the battery, they are covered. There won't be oxidation, there won't be rust, there won't be leakages from the battery. So this is the final connection. As you can see, it's very neat, very nice, very professional job. It's an in-house job, and the whole department, we worked together as a unit to achieve this. Very, very possible. Do some people ask for expatriates from Europe or Asia, but Nigerians, we could really do this on our own. It's quite easy, but it just requires care and concentration, which we did, and it was a huge success. So after the connection was done, this was the terminal voltage at the end of the day, which was 253. Remember, we said it was going to be 240 volts DC, but 253 is okay because the voltage is not 2.2. The voltage is not at 2 volts; it's at 2.2 volts. So connecting 112, you get 253, 254. So this was the Torkel capacity tester kit. After we connected it, we tested it to make sure that okay, the batteries are good. So we put a load, a stationary load. So this Torkel tester acts as a simulation device to simulate any form of load on your system. So it can tell you the rate of discharge of your system depending on the load you use. So this convention, this Torkel is just like a resistance battery bank. A resistance load bank that draws a certain current for a certain time, and it measures the rate of depreciation, rate of charge drop per each cell, so you will know which cells go down quickly and which cells you need to change. So checking the result, all the cells were good, they were all green after a while, and they were all good, and the terminal voltage was stable. We drew about 50 amps. The total amps thereabout was about 100 amps for the lubrication pumps, but if you use 50 amps, it means they'll run twice as longer. So it was very good. So we drew 50 amps. So if you draw 50 amps for 2 hours, you can draw 100 amps for 1 hour. So we drew a lot of current and it stayed for a long time. So the batteries are good. They can last 4, 5, 6 years if well maintained. They can even last up to 10 years if there's no problem. So that's the project. Thank you very much.